Okay, so for this video, we're going to talk about arcs and inscribed angles. So let's first talk about what is an inscribed angle. So from your guided notes that we had at the beginning of the unit, so we went over central angles. That's when the vertex is at the center of the circle. Now we're going to talk about inscribed angles. So an inscribed angle is formed by two chords. And if you're like, wait, what are chords? So let's go back to it. A chord is a segment whose endpoints lie on a circle. So this is a segment, it lies, the endpoints lies on the circle, and it could be anywhere around it. So for an inscribed angle, that's how it's formed, by two chords. Now the vertex is on the circumference of the circle. So the vertex has to be on the circumference. The center angle is at the center point, the vertex. Now we're talking about inscribed angles. It's going to be on the circumference. Now, in order to figure out what the inscribed angle is equal to, or the arc, there's a formula for it. It's your intercepted arc, and you divide it by 2. So you're taking half of your intercepted arc. So your intercepted arc is right here. AC, arc AC. So this is your inscribed angle. So the endpoints of the inscribed angle AC, that's what your intercepted arc is. So right across from it. So whatever that arc is, you're going to divide it by 2, and that's going to help you find your angle, the inscribed angle. Now this formula sheet is what we're going to go over throughout the unit. It is on Canvas under Unit 7, because we're dealing with circles. It's called Circle Formula. It's a PDF, so you could have all of this. So let's just go over this. Central angle, remember the vertex at the center. To get this angle, measure of angle ABC, it's equal to its intercepted arc. So whatever this arc is, AC, this angle is equivalent to it. So now we're going to talk about inscribed angles. So it's right here. So your inscribed angle, the vertex is on the circumference of the circle. So the measure of angle ABC, this angle right here, is going to be half of its intercepted arc. In other words, whatever the arc is divided by 2, that's how you find your inscribed angle. So now we're going to practice with some examples. Okay, so let's look over this example right here. So this is my circle, and we have our inscribed angles. So it says, part A, determine the measure of angle SBE. SBE. So I'm trying to look for this angle right here. Angle SBE. So because its vertex is right here, the angle lies on the circumference, that means whatever my intercepted arc is, I'm just going to take half of it. So this is my angle. So the endpoint of the angle is S and E. This is my intercepted arc. It's right across from the angle. So I'm going to take 52 and then just divide that by 2. So that means the measure of angle SBE is going to equal to 26 degrees. Okay, so that's the answer for the first one. Just should put over here, it's 26. Okay, so next. Now, for part B, determine the measure. This means arc. You're looking for the arc OB. So the arc OB is right here. I want to find what that measure is. Now, we know from here, we said that half of the arc that gives you your inscribed angle. So if I'm given my angle and I want to know what the arc is, all you're going to do is multiply it by 2. So like here, for example, let's say we knew this was 26 degrees. How would I get 52? You multiply it by 2. It's the reverse from what we did. So for part B, all you're going to do is take 2 times your inscribed angle, and that's going to give you 126 degrees. That is the measure of arc OB. Okay, so as long as you remember, just remember that the inscribed angle is half of the arc. So that means if you have the angle to get the arc, you're just going to multiply by 2. Okay, so let's move on to the next example. It says, what is the measure of angle HTA? So I'm looking for angle HTA. I'm looking for this angle here. That's what I'm looking for. What is the measure of that angle? So first of all, let's see what we have. We have a triangle, 67 degrees, and we have this arc. So let's think. This arc, let's find, you want to find what this angle is, right? So let's figure out, do I have an arc here to give me the inscribed angle? I don't. So all I have right now is 67 degrees and this arc, 102. Well, I know that half of the intercepted arc will give the inscribed angle. So this is the arc, right across from it is angle A. So to find the measure of angle A, I'm going to take half of 102. Or just do 102 divided by 2. Which is going to give you 51 degrees. So now I know angle A is going to be 51 degrees. Now how does that help me? Well, inside a triangle, what do the angles have to add up to? The triangles, the angles, the sum of them have to add up to 180. So for me to figure out that angle, I'm going to do, okay, so triangles, angles of a triangle add up to 180. So since I know all three angles have to add to 180, I'm just going to do, okay, so 180 degrees minus 51 degrees minus the 67 degrees will give me the angle T, which will equal to, so let's see, 80 minus 51, which will give me 62 degrees. So the measure of angle HTA equals 62 degrees. And there's more than one way to approach this example right here, because you could have gone with 67 degrees multiplied by 2 to give you your arc, and then to find out the other arc. That's just more work. But this one is just the faster way to do it. But just so you know, there's always more than one way to approach a problem like that. So again, we had only one arc, so we found the inscribed angle. And then we know in a triangle adds up to 180, so we're going to subtract these two angles from 180, and now we know what that angle HTA measures. Okay, and our last example. And if you want to try this on your own, I recommend it. Press pause and see if you get the same answers as me. So it says determine the measure of angle IDE. So let's go find it. Angle IDE. I'm looking for this angle right here. So let's identify. The vertex is on the circumference of a circle, so that's an inscribed angle. Meaning whatever the intercepted arc of this angle is, we'll take half of it. So let's look across. This is my angle. Right across is this arc, 110 degrees. So I'm going to take half of 110. And that gives me 55 degrees. So that means the measure of angle IDE equals 55 degrees. And the last one, it says for part B, determine the measure of the arc TD. I'm looking for this arc, TD. So the arc is in relationship with the inscribed angle. So the inscribed angle, so right across from here, the angle is right here, which is 38 degrees. So remember, because I'm going from inscribed angle to the arc, I'm going the reverse now. I'm going to multiply. So it's going to be 2 times 38 degrees, which will give you 76 degrees. So the measure of the arc, TD, equals 76 degrees. So just to verify, if this was 76, I had to take half of it to get my inscribed angle, and that would be 38 degrees like we had on the picture.